Hello, my name is Brandon Fisher, and in this video I'm going to tell you about some of the controversy that surrounds full-body scanners. Full-body scanners are devices which do just that. They create a nude image of a person and are able to detect objects that would otherwise be covered by clothing. They utilize one of two different kinds of technology to create these images: backscatter X-rays or millimeter waves. A full-body scanner requires no physical contact. Recently, the use of full-body scanners has become more and more controversial since their prominence is greater than ever and growing. The Amsterdam International Airport was the first airport to install full-body scanners on May 15, 2007. Since then, in the United States, they have been used by courthouses and airports and tested at train stations and subways. According to the Transportation Security Administration, or TSA, as of November 20, 2010, there are 385 full-body scanners in use at 68 United States airports. As reported by USA Today, the United States plans to deploy 1,000 scanners by the end of 2011. There are a multitude of reasons why people have stirred up controversy surrounding full-body scanners. There are health concerns, privacy concerns, and effectiveness concerns. Many people argue that exposure to radiation, or repeated exposure to radiation, such as passing through full-body scanners, is detrimental to one's health. In order to understand the effects of full-body scanner radiation, we must first understand the technologies used and how they are applied to the human body. As I stated before, there are two different types of technology which can be used in full-body scanners. They are backscatter X-rays and millimeter waves. An X-ray is a form of electromagnetic radiation. That is, it is an energy which uses a wave-like motion to move through the air. Other common forms of electromagnetic radiation are radio waves, UV rays, microwaves, and even visible light. All of these forms of radiation are capable of moving through various solid surfaces, depending on that solid's density. Where we as humans are concerned is their ability to penetrate our skin. The wavelength of an X-ray is shorter than that of a UV ray, but longer than a gamma ray. Simply put, an X-ray is capable of penetrating human skin, but has trouble going through our bone tissue. X-rays are a type of ionizing radiation, which means they are able to detach electrons from atoms or molecules, which ionizes them. They literally mutate cells, more specifically our skin cells, since they change their structure. The way backscatter X-rays work is slightly different from traditional X-rays. A backscatter X-ray only shows the particles that reflect off of what is being scanned. When an X-ray hits the surface, it creates a physics phenomenon known as scattering, where it diverts from its straight line trajectory. This is known as the law of reflection. It can best be demonstrated by shining a flashlight at a wall or pouring water onto the ground. A full-body scanner will use the information from the reflected waves to generate an image. Because of this, backscatter X-ray machines create only a two-dimensional image and can only be used on one side of a person at a time. Full-body scanners which use millimeter waves actually operate pretty differently. A millimeter wave lies between a radio wave and the waves which we commonly refer to as lasers. This wave is known to operate in the terahertz range, and evidence to show its effects on the human body are mixed. While some studies have produced results with no effects on humans, others, such as research from the Los Alamos National Laboratory in New Mexico, have shown terahertz waves to unzip DNA strands and interfere with DNA replication. Millimeter wave technology is used in full-body scanners because clothing and most other fabric-like materials are translucent in the terahertz range. A millimeter wave scanner uses two antennas which rotate around a person and create a three-dimensional image which can be viewed on a monitor. Now, let's analyze the arguments for why full-body scanners are harmful to the human body. Researchers, including the head of the Center for Radiological Research at Columbia University, argue that the amount of radiation a person is exposed to in a full-body scanner is larger than what TSA and the device manufacturers state. Safety studies were calculated as if radiation were being evenly distributed throughout the entire human body. However, with a backscatter X-ray scanner, we know this is not the case, since it only targets the skin and surrounding tissues. Proponents of full-body scanners commonly compare backscatter X-ray radiation to be the equivalent of just a few moments of in-air travel time, also known as cosmic ray exposure. However, cosmic ray exposure targets the whole body and is considered a relatively safe dose, because of this surface area to volume ratio, while backscatter full-body scanners only apply radiation to very small, specific parts of the body. Other opponents of full-body scanners, such as researchers from the University of California, San Francisco, bring up that defects in the machines, software errors, and normal wear and tear can cause a full-body scanner to focus an intense dose of radiation to one small area of the body. They cite cases of typical medical scanning machines that malfunction during use and cause serious injury to patients. Despite these arguments against the safety of full-body scanners, the National Council on Radiation Protection and Measurements, the American College of Radiology, and the Health Physics Society all state that they are not aware of any evidence that full-body scans are unsafe. The International Atomic and Nuclear Energy Agency suggests that women who are pregnant and children do not use full-body scanners, as not enough long-term studies have been done to determine the health effects of them. Another major concern many people have with full-body scanners is their infringement upon privacy. In July of 2010, the Electronic Privacy Information Center, or EPIC, filed a lawsuit in an attempt to halt the use of full-body scanners in airports in the United States. EPIC claims that the TSA has violated the Privacy Act of 1974, the Religious Freedom Restoration Act, the Administrative Procedures Act, and the Fourth Amendment to the United States Constitution, which protects citizens against unreasonable search and seizure and requires search warrants to be supported by probable cause. Opponents of full-body scanners state that strip searches without probable cause, even though virtual, violate basic human rights. The American Civil Liberties Union supports the claim that full-body scanners are an invasion of privacy and points out that they do not only reveal genitals, but also body size, body shape, and other things such as evidence of a mastectomy, prosthetic limbs, or catheter tubes. Anomalies such as these would require a hands-on physical inspection once they were detected, and to many people, could cause unnecessary embarrassment. Proponents of full-body scanners have a simple argument: how much is your safety worth? While full-body scanners cannot be guaranteed to prevent acts of terrorism, there is still a great deterrent. The less possible it is for a terrorist to execute an attack, then the safer the airline's passengers are. The ethical question we have to ask ourselves is, where do we draw the line? Furthermore, advocates of full-body scanners highlight the fact that airline travel is a privilege, not a right. Your interest in flying on a commuter airline is probable cause for both search and seizure. The last majorly important aspect of full-body scanners which causes controversy is their effectiveness. Opponents of the scanners claim that a person can place explosive contents on their body in such a way that they cannot be detected. Supporters of scanners agree that while this could possibly be true, creating an actual weapon, not just transporting explosive material, may consist of more than just scattering trace amounts of a substance all over one's body. Alternative methods of full-body scanners that have been suggested by many are sniffing machines or dogs and chemical-based scanners. But to retort, advocates of scanners are aware of more weapons than just those of chemical type. Without full-body scanners, how easy would it be for a terrorist to conceal a plastic weapon? While valid arguments exist on both sides of the spectrum, the ultimate judge on the use of full-body scanners in airports will be the American people. Will people be willing to perhaps sacrifice some of their rights and health for a reassurance of safety, or will Americans stand together and protest in an effort to force the TSA to retract their decision of the implementation of full-body scanners? Only time can tell us.